Boys, now because I have explained about nature of roots, so I try to make one more additional information for your reference about chapter 6. I try to revise it very fast. We try to show this is a factor of a polynomial. So how should you do? You try to use remainder theorem, set the factor as 0, then you substitute -1 into the function. If I left fx, so you try to check that -1 3 plus 1, which is equal to 0. So we know x plus 1 is a factor of fx. And then if you have to solve, usually part B will ask you to solve this function equal to 0, the roots. So that means you are going to find the roots of equation. Then adopting the idea of factorization. So what you are going to make use of part A result. Usually we try to make a long division. X plus 1. And then you try to do long division step by step. And remember minus 0 to x squared. And then do it once again. So -3. Now usually if you did it in part is correct, the remainder must be 0. So and then if you can calculate carefully and then you find out this, so you are very happy because you did a good job. So after that because it's factor and then this is quotient, therefore the next step becomes factorize. That means the divisor times quotient becomes 0. Okay? 即係呢兩個乘埋就係呢個 OK? And then we try to do, because it's equal to 0, then the factor equal to 0 or this quadratic equation equal to 0. Then we know first x equals to -1. We know one of the roots. Or these two. By using your calculator, you can find out x equals to -3 or x equals to +1. So from these, therefore, now usually you can find, sometimes the question may have a little bit change. So I can say few different conclusions for you. So we have 3 roots, or we have 3 distinct real roots, or sometimes you can see the nature, 3 distinct integers. Okay. So remember, I think the basic thing is not quite difficult to understand. You always think about try to make the equation keep into something times together by factorization, but we don't know how to do the keep to doing factorize except the identity. Except this, you know this from form 3. So except this kind of identity you can factorize easily. Usually we use chapter 6 long division by proving first factor, do long division, and then put it together equal to 0, and then we solve. Remember, solve equations, that means set the polynomial equal to 0 and then find the values of x. Then you can do them quite well. Okay?